an infinite number of irrationals, also between 0. Hey, let's use the electron microscope, and let's blow up the number line just immensely, and let this be 1, and let this point here be 1.000. Get the idea? They're really close together. Got the idea? I mean, they are so close together that if they were on a number line like that, you couldn't even tell that they were two different points. These guys are like next-door neighbors on the real number line. Probably barbecue together on the weekend, carpool together. Yeah, they're real close, all right? Question.
Infinite.
That's right. How many rational numbers do you think there are between these two numbers?
Infinite.
How many irrationals?
Infinite.
You pick any two real numbers, no matter how close you think they are. I mean, use your imagination and put them just as close as you can imagine them to be. There are still an infinite number of both rationals and irrationals between those two numbers. That's why we say, ladies and gentlemen, the real number line is completely filled. It is full of numbers. There is no way you could blow it up under an electron microscope and just get a bunch of dots that are numbers and a bunch of empty space in between. No empty space. No empty space on the real number line. You put the rationals together with the irrationals, you got our set of real numbers. Hey, what are rationals? They're decimals that either repeat or terminate. Irrationals are ones that do neither one of those things. So when you put them together, you got all the decimals. Anything that can be expressed as a decimal is a real number. If you can express it as a decimal, it's a real number. So, big question, ladies and gentlemen. Is 7 a real number?
Yes.
Can you express that as a decimal?
Yes.
Okay. Like?
7.0.
7.0. Hey, is 0 a real number?
Yes.
You can express it as a decimal?
0.5.
I'm sorry. 0.5.
0.0.
Yes, thank you very much. 0.0. Since I can't express it as a decimal, anything I can express as a decimal is a real number. All right? Is this a real number? Yes. Absolutely. Put that in your calculator. It'll help you. It'll give you the decimal that is represented by that fraction. All right. One thing I forgot to show you that I do want to show you is something about rational numbers. When we talked about rational numbers, did we use a listing method or a description method to talk about rational numbers? Description, right? Let's do it the other way. Let's talk about all the rational numbers and let's list them. In fact, let's not even worry about the negative rational numbers. Let's just talk about the positive ones. Not even 0, just the positive fractions, okay? What's the first fraction in our list? The smallest fraction?
1.
The smallest fraction. the tiniest fraction. The one right after 0.
1 over 1?
Is what?
1 over 1?
1/2. Okay. So that's the smallest fraction, right?
No.
Is the fraction smaller than that?
Yes.
Like? Yeah, that's smaller. Okay. So what is the smallest?
The infinite number.
I don't understand this infinite. So if I ask you the question, what is the smallest positive fraction, what's your answer?
Infinite.
I'm sorry, what? There is None.
Oh.
There is no smallest positive fraction. Here's why, ladies and gentlemen. You give me what you think is the smallest positive fraction, I'll divide it in two and give you half of that. Make it smaller still, right? So just that logic in itself lets you know that there is no smallest positive fraction. Everybody got that picture? No smallest positive fraction. Pages are starting to turn. Is that indication of something? Missing something? Any questions? All right, I'll see you guys on Thursday. Hey, come up and check the list if you're not sure you're on this class.